In this section, we're going to start taking a look at truth tables, truth values, and being able to use truth tables. And so when we start talking about a truth table, the first thing we have to understand is a truth value. And a truth value is the value that we're going to be placing on a statement, whether it's true or false. Because I remember, as definition, a statement is either true or false, but not both. For a conjunction to be true, remember, for a conjunction to be true, both of the statements must be true. So, and remember, conjunction is an and. For a disjunction to be true, one of the two statements must be true, either, and it doesn't matter which one. And so remember, a disjunction is an or. And then finally, for a negation to be true, and remember, negation is a not, then the original statement must be false. All right, so now we're going to see this with a truth table. All right, but these are just some of our basic definitions as we're going along here. So what is a truth table? Well, a truth table basically tells us all the possible outcomes for a statement, whether it be simple or compound, and all the associated truth values. If we have n simple statements, then there are going to be 2 to the end rows in our truth table. So for example, if I had something like P and Q, notice that there are 2 simple statements, whatever P and Q might be, and that means that 2 square is going to be equal to 4 rows. If for some reason we had something to the effect of, and I'm not going to do this to you, but let's say we had P and Q and R or S, that means we have n equals 4 statements, and that means that 2 to the 4th is going to be equal to 16. So we would have 16 rows in our truth table, all right? So that's one of the first things that we have to make sure of, is that we can construct the truth table appropriately, and to construct it appropriately, we have to know how many different rows that there are going to be. The most I'm likely to give you is 3 statements, which means you would have 8. So let's start off with the really basic idea of how to do a truth table. And to do a truth table, or to fill out a truth table with the truth values, what we're going to have to do is we're going to have to start with these 4 most simplistic forms. Now remember, this one is a conjunction, so this is an and this is our or. This is our if-then. And then finally, this is our not. So how are we going to fill this in? Well, 3 of them are pretty easy. Because remember, we said that for a conjunction to be true, both of the statements must be true. So for instance, let's say P was I'm a teacher and Q was I am rich. That means that I'm a teacher and I am rich. If they're both true, then the compound statement must be true. In any other case, these are all going to be false. All right, so these are the outputs right here. All right, so this is what you want to memorize. All right, this is the most important part right here, to memorize what happens with a conjunction. With a disjunction, remember we said that only one of the 2 needs to be true for a disjunction to be true. So in this case, if P is true and Q is true, then P or Q is true. And then similarly, if only one of them is true, then P or Q is true. And then finally, if they're both false, then they're both going to be, then the output's going to be false as well. All right. Now, the one that's tricky, I'm going to skip the if then for now. I'm going to come back to that. This one's pretty easy with the not. Remember, if we negate a true, it's a false. If we negate a false, it's a true. All right. So again, these are what you want to memorize. All right. So these outputs, because we're going to be using these a lot throughout the semester. All right. Finally, we have to understand what's going to go on here with the if-then statement. And the way I always try to teach this to students is to think of the statement, if I study, then I will pass. Right? So let's say you study and then you pass. I haven't lied to you. So that would be a true statement. As the teacher, I haven't lied to you. Let's say you study, but you don't pass. Well, then I've lied to you. So this is false. What if you don't study, but you do pass? Well, I haven't lied to you. You've gotten exactly what you wanted. You passed even though you didn't study. What if you didn't study and you failed? Well, I haven't lied to you as a teacher. So that means it's true. All right. So that might be the easiest way to try to remember the if then. If I study, then I will pass. And again, this is what you want to memorize. Okay. So these are the most elementary components of the truth tables. And from here, what we're going to do is we're going to start building a truth table from a compound statement. All right. So let's start off with this animal right here. We have P and Q, or not P or R. Right. Now, first thing we need to know is that we have to have 8 rows. All right, so n is equal to 3 because there's a P, there's a Q, and there's an R. And so that means that we are going to have 2 to the third, which is equal to 8. All right, so here's how we're going to do this. All right, it's actually not too difficult once you see it a few times. So we have a statement P, we have a statement Q, and we have a statement R. All right. And the 8 possible permutations, okay, here's the easiest way to do this. Do 4 trues followed by 4 falses. Right? And again, this the way I'm showing you, this is going to help you to be able to get all the different permutations of P, Qs, and Rs for the truth values. So you've done 4 and 4. Now do 2 and 2. So do true, true, false, false, true, true, false, false. And then now it's going to be on every other. So it's going to be true, false, true, false, true, false, true, false. That's probably the easiest way to draw a truth table. All right. Now, what we're going to do is we're going to start just like you would in algebra, is you would just do what's in parentheses. So now we have a column of P and Q. All right. Remember, we said that for this statement to be true, P has to be true and Q has to be true. So right here, we have a true and a true, which means that the output for P and Q is true. Once again, we have a true and a true. So that means the output for that is true. Notice we don't even care what R is right now. Okay, so just to ignore R. All right, it's not doing anything to help us. All right. Now, as soon as we see a false, the conjunction is false. All right, so right here is false, and then we have a false here, and then we have a false here, and a false here, and a false here, and a false here. So the rest of these are all going to be false in this row. All right, so that's the nice thing about a conjunction is that as soon as you see a false, you know that the conjunction is false. All right. Now, next thing that we have to do is we have to construct not P or R. Right? So not P or R, well, what does that look like? Well, not P is going to be false, 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 true, 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 true. So it might be helpful for you just to start with the not P column, if that helps. All right, you don't have to do this. If you want to do it in your head, that's fine. But not P would be false, 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 false. And all I'm doing is I'm just looking at these trues, and I'm just changing them over to falses. And then in a similar vein, I'm going to change all the falses to trues. So this is going to be true, 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 true. Right. Now I'm going to have a column for not P or R. All right, so now remember with the disjunction, as soon as you see one true, that means that the entire statement is going to be true. All right, so here's what I like to do. I like to just go down the list and find trues. So I have a true here, so this is true, 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 true. All right. So notice that as soon as you see a true, that means the disjunction is true. And now I'm going to look at R. Well, I have a true here and a true here. So that means that this is true and this is true. Now notice that R is false and not P is false. So since they're both false, that means the output is false. All right, and then the same thing in row 4 here, that's false. All right, one last line to be able to construct this truth table in its entirety. And that's going to be the final line. All right, in other words, what are we looking for? Well, we're looking for P and Q or P, not P or R. So that's going to be right here. That's going to be P and Q or not P or R. All right, so to do that, just like we did before, we have a disjunction, all right, which means as soon as you see a true, you just write a true in there. So notice right here we have a true, and here we have a true, and we have 4 trues right here. So true, 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 true. Now, the other column we need to look at is this animal right here, right? And so as soon as we see a true, so notice right here we have a true, and so that means that this disjunction is true. But notice that both these are false. All right, so right here, this is false. And this is the output column that we were really looking for. All right, so all of that was just to get to right here. Okay, so essentially, everything is going to be true. It's almost a tautology, except for one guy that makes it just a regular old statement. Okay, so a suggestion might be before you watch the next video is to just work this one on your own. Right? See if you can do this, all right, by using what we just did before, and then go to the next video and see if you can follow that just to make sure that you're on the right track, and if you're not, to be able to resolve any issues that you may have had.